Hello students, this chapter is continuation of the previous chapter of equilibrium of coplanar forces. In the equilibrium chapter, we had not considered friction. All surfaces were considered to be smooth. In this chapter of equilibrium, all surfaces will be considered to be rough, so that friction between the rubbing surfaces will also come into consideration. As far as application of equilibrium conditions is concerned, it will be applied in the same manner, right? The additional force which will come across in this chapter is frictional force. So students first will have understanding of initial theoretical concept related to the friction chapter. This chapter will cover in 2 lectures. This is the first lecture of the topic. Let's understand what is friction. Friction is resistance to sliding between the two surfaces in contact. Friction force is distributed over the entire surface of contact. Friction force acts tangential to the surface in contact. It acts in the direction opposite to that of impending motion or motion. Friction is of 2 types. One is dry friction, another is fluid friction. Dry friction means friction between the two surfaces in contact in dry state, like friction between the tires of the vehicle and the road surface during the dry climate. It's dry friction. Fluid friction is the friction between the two surfaces in contact in the presence of some fluid, that is called as fluid friction, like friction between the tires of the vehicles and the road surface during monsoon when the roads are wet. That is called as fluid friction. Fluid friction is always lesser than dry friction. But as far as our subject is concerned, our syllabus is concerned, we are going to deal with only dry friction. Next, we will discuss limiting friction. Now, to understand the concept of limiting friction, you will have considered a body of weight W. All right, it is subjected to gradually increasing force P towards right. So, if there is a gradually increasing force P towards right, that means in any case, body will have the tendency to move towards right. So, I'll use this as a notation: arrow with double head, which will be the direction of impending motion. As you apply the force towards right and surface is rough, then friction will generate in the direction opposite to that of impending motion. Initially, friction force F will continue to increase with the increase in the value of P. But a stage will come when friction force F will attain the maximum possible value, and beyond which, if the value of P is at that stage, F is equal to P. Now, further, if the value of P is increased, the body will begin to move. So, we define limiting friction like this. Limiting friction is the maximum friction which comes into consideration between the two surfaces in contact when the body is just about to move. All right. And once the body is in motion, that friction force gets reduced. All right. And as dynamic friction is lesser than static friction. This will discuss further at length. Now we come to next is laws of dry friction. At the time of impending motion, limiting friction force F is directly proportional to normal reaction. You can see that on this side. At the time of impending motion, friction force F is directly proportional to normal reaction, or we can say F is equal to mu s n. Mu s is coefficient of static friction. All right, and F is force required to just start the sliding or impending motion as a normal reaction. Mu s is coefficient of static friction. Next is when the body is in motion, the friction force which comes into consideration is kinetic friction. All right, and which is equal to mu k n. Mu k is coefficient of kinetic friction. In general, it is all mu k is lesser than mu s. I mean, mu s value is greater than mu k value. Coefficient of friction is independent of area of contact. Now, for solving the problems, we need to remember certain points for solving the sum. I have listed over here. Friction force F between the two surfaces contact can be any one of the following. If the body is at rest, friction force will be F only. It has no relation with normal reaction. When body is in impending motion, friction force F is equal to mu s n. Mu s is coefficient of static friction. And when the body is in motion, friction force is equal to mu k n. So these 3 points, students, are very, very important for solving the problems of friction. In general, if you are solving the problem of statics and only mu is given, it is treated as mu s. When you are solving the problems of dynamics and only mu is given, that is treated as mu k. Next, another very important term. Now I'm coming to important term as from examination point of view, angle of friction. Now, just now we have understood that friction force is directly proportional to normal reaction, and F, if the body is on the verge of motion, friction force F is equal to mu s n or mu n, you can say that. Now, angle of friction is with reference to the limiting equilibrium concept just now what we discussed. So, normal reaction will act vertically upward. If the body has impending motion towards right, friction force will act towards left. So, you want to find resultant of normal reaction and friction force F. So resultant force, resultant of these two will make angle phi with the vertical, and that's what is called as angle of friction. So how we define angle of friction? Angle of friction is the angle which the resultant of normal reaction and frictional force makes with the direction of normal reaction at the time of impending motion. So what will be tan phi is equal to F upon N. What is F? Is mu n, right? So nn gets cancelled and you get the value of phi. Tan phi is equal to mu, or mu is equal to tan inverse, phi is equal to tan inverse of mu. So when you are solving the problems of static, students, if the coefficient of static friction is given to you, you can find angle of friction. Mu is equal to tan phi using that relation. And if phi is given to you, then mu is tan phi, that also can be used. Now we come to the next term, which is cone of friction. See, cone of friction has no much relevance with the solution of the problems of friction or solution of the problem of this chapter. It's just a theoretical term. Now, just now you saw that in the previous article, angle of friction is the angle what the resultant of normal reaction and friction force makes with the direction of normal reaction. So, suppose you consider a block where impending motion is to the right, friction will act towards left. In that case, normal reaction is vertically upward. Resultant of 2 will make angle phi with vertical. This is one direction impending motion. Suppose I assume direction of impending motion is towards left. Friction force will be tangential to the surface towards right. Normal reaction will be vertically up. So in that case, resultant of the 2 will be making angle phi with the vertical. So if you consider various directions of impending motion of the block around one position, you'll find that whatever is the direction of impending motion, friction force will be in opposite direction. Friction force will be horizontal only. Normal reaction is vertical. So resultant of the two in all possibilities or all positions of impending motion will always be making angle phi with vertical. So you can say that for various directions of impending motion, resultant of normal reaction and friction force will make angle phi with the vertical, or we can say that resultant of normal reaction and friction force for various directions of impending motion around one position will lie on the surface of an inverted cone with semi-vertex angle phi. Such an imaginary cone is called as cone of friction. So cone of friction is a inverted cone on the surface of which resultant of normal reaction and friction force will lie for various directions of impending motion. Important term from theory question point of view in the examination. Next, we come to angle of repose. This term is also important. Angle of repose. Now, we have a body of weight W. It is kept on the horizontal plane. Plane is rough. We make the plane inclined. I'm making initially the plane was horizontal. I slowly started tilting the plane, and you'll see that initially the body will remain at rest, but a stage will come when body resting on the plane will just start sliding. So at that stage, inclination of the plane with the horizontal is called as angle of repose. So we define angle of repose like this. Angle of repose is the angle which the plane makes with the horizontal at the instant when the body resting on the plane without any external force just starts sliding down. So for that case, I have drawn the free body diagram here. You can see that this is the block resting on inclined plane, weight is vertically down. Inclination of the plane is theta with the horizontal. You know that from the previous chapter of equilibrium, we learned that if the plane is making angle theta with horizontal, normal reaction will make angle theta with vertical. So this angle is theta, this will be theta. All right. So also we should remember that whenever a body is resting on inclined plane, we always take x along the plane. What we do that? We take x along the plane and y normal to the plane. This way, x and y references are taken, and then accordingly sigma fx and sigma fy are applied. Do remember that for this chapter, whenever the body is resting on inclined plane, we'll always take x reference axis along the plane and y normal to the plane. So keeping that in mind, see, weight is vertically down, plane is making theta with horizontal. So this is the direction of normal reaction. We make angle theta with vertical. So this is W cos theta, W sin theta. All right. The body is on the verge of going down. Friction will be acting up. So we apply sigma Fy Fx is equal to 0. So sigma Fx is equal to 0 is mu n is equal to W sin theta. Sigma Fy is equal to 0 is n is equal to W cos theta. Right. Substitute the value of n, or from solving equation number 1 and 2, you get mu W cos theta is equal to W sin theta. W gets cancelled. You get tan theta is equal to mu is equal to phi, or theta is equal to phi. So what we find that angle of repose is numerically equal to angle of friction. So when angle of repose is just equal to theta, angle of repose is numerically equal to angle of friction, the body is on the verge of sliding down. So we can draw the conclusion in this manner. Thus you can see that here I've written the important conclusion. When angle of repose, I mean theta is less than phi, body will be at rest. When theta is just equal to phi, body will be on the verge of motion. And if theta is greater than phi, body will move down. So this is, but keep that in mind, concept of angle of repose is applicable only when there is no external force on the. Friends, we are ready to start solving the problems of type 1, that is block friction. I'm reading question number 1. A car of one. Most of these problems have been taken from the Mumbai University examinations. Also, few problems have been taken from the autonomous institutions like DJ Sangvi or SPC or BJTI, etc. Now, a car of 1000 kg mass is to be parked on the same 10-degree incline year round. Static coefficient of friction between the lines and the road varies between extremes of 0.05 and 0.9. Is it always possible to park the car at this place? Assume that car can be modeled as a particle. Well, students, first is that small printing error is there. This is not line, it is tires. Between the tires and the road surface. This is tires, the road surface, slight printing error. Anyway, now, in this chapter, what you need to remember that if the dimensions of the body are not given, of course, this assumption is applicable in the entire subject, but right now its significance is there. So I'm just in this chapter, if the dimensions of the body are not given, it is to be treated as a particle. That means we have to consider the force system as concurrent. We will apply two equilibrium conditions, sigma fx and sigma fy is equal to 0. All right. And if the dimensions are given, then we take it as a rigid body, and then it reduces to general force system. You'll see that we'll come across, initially we'll take the problems where dimensions of the body are not given. So free body diagram becomes example of concurrent force system. At later stage, we'll have few problems where dimension of the body will be given so that it becomes example of general force system. It's a very interesting fact that in friction chapter, we do not come across parallel force system. Why we do not come across parallel force system? It is because friction force and normal reaction itself are mutually perpendicular. So there is no question of parallel force system coming into consideration. Now, for the given problem, what is given? Mass is given 1000 kg, theta is 10-degree inclination of the plane. Mu minimum is given to 0.05. So I can write is equal to 10 phi minimum. Taking 10 inverse, you get phi minimum as 2.86. Mu max is given 0.9. So that is 10 phi max. Phi max is 41.9. Now, inclination of the plane is 10 degree. During for the extremes of mu values, phi minimum is 2.86. So there will be an instant when theta is greater than phi. During the year, there will be some period when theta is greater than phi. When theta is greater than phi and car is a particle, the car will begin to move down the plane. So it is not safe to park the car at this place throughout the year, because at certain period of the year, theta is greater than phi. So car will go into motion. Now, as this question was asked for 5 marks and it is based on angle of repose theory, So angle of repose theory should be explained. Then only 5 marks question, 5 marks would be justified. If this question was asked for 2 marks or 3 marks, then there was no need to explain the angle of repose theory. And why angle of repose theory is applicable, concept is applicable, because there is no external force given in the given on the. Now we move to second problem. It's on the right side. If a horizontal force of 1200 Newton is applied horizontally on a block weighing 1000 Newton, find whether the block will be in equilibrium or slide down or move up. Also find actual friction given US is 0.3, mu k is 0.25. Student, here certain important point I have listed, which I have already discussed in my previous problem itself. Right? I again quickly repeat them. If the plane is making angle theta with horizontal, reaction normal to the plane will make angle theta with vertical. If the dimension of the body are not given, free body diagram will reduce to concurrent force system. If the dimension of the body are given, it reduces to general force system. And whenever the body is kept on the inclined plane, we take x reference axis along the plane and y reference axis normal to the plane, and then equilibrium conditions are applied. So free body diagram of this body, we will we have drawn it on the next slide. I'll just change the slide. Now we have drawn the free body diagram of this body. Weight 1000 Newton will act vertically down. Normal reaction will be perpendicular to the plane. Plane is making 30 with horizontal, so reaction normal to the plane N1 will make 30 degree with vertical as marked. 1000 as we will be taking x along the plane and y normal to the plane, so all forces should be resolved along the plane and normal to the plane. If this angle is 30 degrees, so this is component is 1000 cos 30 down and 1000 sin 30 down this. So 1000 has been resolved, weight has been resolved along the plane and normal. Now we come to this 1200 Newton force. This 1200 Newton force is horizontal. All right. This line is parallel to plane. This line is parallel to the plane. That means this theta and this theta will be like alternate angles. Right. This is 30 degree and this angle will also be 30 degree. Why 30 degree? Because this plane and this line of action are parallel. We are right. So based on that, 1200 can be resolved 1200 cos 30 and 1200 sin. Now we'll write sigma Fy is equal to 0. This free body diagram is without dimensions, so it will be example of concurrent force system. So first we'll write sigma Fy is equal to 0. Sigma Fy is equal to 0 when I write N1 up is equal to 1200 sin 30 down plus 1000 cos 30. So you get the value of N1 as 1466. Now students, here we have to find out whether the body is on the verge of going down or on the verge of going up, or it is at rest. So in such a situation, I'll summarize the forces acting along the plane excluding friction. I mean active forces, because friction is a passive force. So I'll take forces up the plane positive. So sigma Fx, I'm doing it. So 1200 cos 30 is up, that is positive, minus 1000 sin 30. 1200 cos 30 is positive. I'm taking forces along the plane up positive. 1200 cos 30 minus 1000 sin 30. So this comes out to be plus 539.23. That means 539.23 Newton up. So net force, net active force acting on this body is up the plane. So that means this body cannot move down. And if net force, net active force is up the plane, friction force will act down the plane as we have marked it in the diagram. All right. What will be the maximum friction force which will come into a consideration in this problem? Mu s N1. Mu s is 0.3 into N1 is 1466, 439.8. Now, if as in the given problem, sigma Fx active forces, applied forces more than maximum friction, that means applied force or active force will overcome the friction. So block will move up the plane. As the block is going to move up the plane, it is in motion. So actual friction will be mu k N1. So mu k is 0.25 into N1 is equal to your mass. Hope this is understood to everybody. Well, now we move to the next sum. Question number 3. A block of weight 800 Newton is acted upon by horizontal force P as shown in the figure. If the coefficient of friction between the block and incline Our mu(s) is 0.35 and mu k is 0.5. Determine the value of P for impending motion up the plane. You have been given a block of 800 Newton. It is subjected to horizontal force P towards right. He is asking you to find out the value of P required so that motion will impend up the plane. Now we draw free body diagram. This is the block. Its weight is 800 vertically down. Normal reaction N1. All right. Plane is making 25 degree horizontal. Reaction normal to the plane will make 25 degree with vertical. ये है वाला है. ये 25 degree है between normal reaction and vertical weight. So 800 can be resolved. Normal to plane 800 cos 25 and along the plane 800 sin 25. The force P again is going to make 25 degree angle here. कैसे निकाला है 25 degree? ये again मैंने जैसे पिछली प्रॉब्लम में बोला था, ये लाइन और ये plane they are parallel. This plane and this line of action of force is parallel. So that means this 25 degree and this 25 degree will be alternate angle. So this angle will be 25. So you resolve P. P cos 25 and P sin 25. And he is asking you to find out the value P required for impending motion of the plane. Friction will act down the plane and friction will be mu(s) N1 because block is on the verge of moving up. So friction will act down the plane. This is my symbol which I'll use it in the problems for direction of impending motion. First we mark direction of impending motion, then we mark direction of friction in opposite direction. Now first we write sigma Fy is equal to 0, N1 up is equal to P sin 25 plus 800 cos 25. Sigma Fx is equal to 0 will give me P cos 25 up the plane is equal to 0.35 N1 plus 800 sin 25. Solve 1 and 2, you'll get N1 as 1054.86 and value of P as 780.4. Students, in these problems, the most important thing is that you should draw the free body diagram properly. Once you have drawn the free body diagram properly, there is nothing much left out in the sum. You have to simply apply sigma Fx and sigma Fy is equal to 0, and you'll see that there will be two unknowns on the free body diagram. And free body diagram will be example of concurrent force system. Before we apply the equilibrium condition, we'll resolve all the forces along the plane and normal to the. Now, we are ready to move to next problem number 4. A support block is acted upon by two forces as shown. Knowing that coefficient of friction between the block and incline mu(s) is 0.35, mu k is 0.25, determine the force P required to keep it moving up and to prevent it from sliding. Now you can see that there is a support block. It is subjected to horizontal force P, right, towards left, weight 800 is vertical down. Now, if you want to find the value P required to keep the block moving up the plane, that means it is in motion. So we'll draw the free body diagram accordingly. Weight 800 vertically down, normal reaction N1 up the plane, normal to it. This is plane is making 25 degree horizontal, reaction normal to it will make 25 degree vertical to this angle is 25. Then we resolve 800, weight is resolved 800 cos and 800 sin. Again, in the same manner as in the previous problem, this angle will be 25 degree as alternate angle of it, right? So P cos and P sin. This time impending motion is up, friction will be down. As the body is in motion, friction will be mu k N1. So that is 0.25. So in this case, when the body is in motion, sigma Fy is equal to 0 will be still valid. Why sigma Fy is equal to 0 is still valid? See, motion of the body is along the plane. There is no motion normal to the plane. So body is still considered to be in static equilibrium normal to the plane. So first we write sigma Fy is equal to 0. So what is that going to be? Up forces is N1 equal to down forces P sin 25 plus 800 cos 25. Now sigma Fx. I cannot write here sigma Fx equal to 0 since the body is in motion. So what I'll write? Sigma Fx will be equal to ma. What will write? Sigma Fx is equal to ma. Can you see that here? But my problem is that if I take sigma Fx equal to ma, problem is of dynamics, problem is of motion. That's correct. But I cannot solve this problem because there are three unknowns in that case. There are three unknowns in that case. So to overcome that difficulty, we'll have to make some assumption. What I'll make the assumption? Assuming that block is moving up at constant velocity. It's moving up at constant velocity. If the block is moving at a constant velocity, then my acceleration will be 0. So with that assumption, I can solve this problem. So I can write sigma fx equal to ma, which I had written. I can write sigma fx equal to 0. So in that case, now we write sigma fx equal to 0. Sigma fx equal to 0 along the plane. P cos 25 is up the plane is equal to 0.25 n1 plus 800 sine 25. Solve equation number 1 and 2. You get n1 and you get p. Now we come to second case. In the second case, to prevent it from sliding, students, here you need to understand this note carefully what I have written. Sorry. Whenever they say that block is on the verge of sliding down, or to prevent it from sliding, to prevent it from falling, that means what it is? It is on the verge of the block or body is on the verge of sliding down the planes. Body is on the verge of sliding down the plane. So, and now we draw the free body diagram with that understanding. Weight 800 Newton vertically down. Plane is making 25 degrees horizontal, reaction normal to it 25 degrees vertical. Resolve the weight 800 cos, 800 sine. This is 800 sine. This is 25 degree alternate angle 25. So P cos, P sine. Impending motion is down the plane, friction is up the plane, mu s n1. Apply sigma Fy is equal to 0, up force is equal to down, n1 is equal to P sine 25 plus 800 cos. Sigma Fx is equal to 0 gives you P cos 25 up the plane plus 0.3 n1, 35 n1 is equal to 800 sine 25. Solve these two equations, you get n1 and you get value of. Here in this problem, it can be observed that value of P required to hold it or to prevent it from sliding or falling down is a very small force is required. That is what is 80. Now, we take next sum, question number, problem number 5. A block of weight 1000 Newton is kept on rough inclined surface. Find out the range of P for which the block will be in equilibrium. You are given with the diagram on which he is asking to find the range of the values of P, so that for the limiting equilibrium, for the equilibrium of this block, force P is applied up the plane. So there are two possibilities of impending motion. One is impending motion up the plane. Another is possibilities impending motion down the plane. Because even if you are applying a force applied is very big, so impending motion will be up the plane. Force applied is very small, so impending motion can be down the plane. So we'll consider two possibilities of impending motion. Like case 1, impending motion up the plane. So accordingly, we draw free body diagram. Can you see that? Weight is 1000 Newton vertically down. Plane is making 30 degrees horizontal. Reaction normal to the plane will make 30 degrees with vertical. So 1000 cos 30, 1000 sin 30. Impending motion is up the plane. Friction will act down the plane. What is that? Is 0.15. Right, sigma Fy is equal to 0, n1 is equal to 1000 cos 30. Sigma Fx is equal to 0, P is equal to 0.15 n1 plus 1000 sin 30. This is what is shown on this side. Sigma Fy is n1 is equal to 1000 cos 30. Sigma Fx is equal to 0, P is equal to 0.15 n1 plus 1000 sin 30. Put the value n1 here, you get the value. So this is the value P required for the impending motion up the plane. Now we'll take impending motion down the plane. So what change will come in the free body diagram? Weight is vertically down. Normal reaction will be still in the same manner. 1000 cos 30 and 1000, the resolution of the weight along the plane and normal plane in the same manner. Applied force is still up the plane. If impending motion is down the plane, friction will act up the plane. If impending motion is down the plane, friction will act up the plane. That's what the change is going to happen. Right? Sigma Fy is equal to 0, n1 is 1000 cos 30. Sigma Fx is equal to 0, P plus 0.15 n1 is equal to 1000 sin 30. Solving the two equations, you get the value of P as 370.5. Friends, I have covered all types of the problems are covered in the video lecture. In the colleges, when teachers will get limited time, so they will not be in a position to cover many problems. They will cover hardly 4 or 5 problems, although I'll be covering here about 25 problems in my video lectures. As far as my book is concerned, in which I have given around 35 to 40 problems are solved given in the book. There are many unsolved problems given, right? And MCQs are also given in my book. You can buy this book from the of engineering mechanics from the local bookstores, or you can buy it from the Amazon. Link of Amazon is given the video description of the lecture. All right. And please do refer this QR code to your friends. Share it with your friends so that they can also be benefited from my free video lectures. There is no need to join tuition in mechanics now, as my video lectures are free to all. Even if somebody does not buy the book, still he can get the good benefit from my video lectures. Now let's come to the next sum. Problem number 6. Determine the force P to cause the motion impend. Take mass of the blocks A and B as 8 kg and 4 kg respectively. Coefficient sliding friction as 0.3. The force P and rope are parallel to inclined plane. Assume frictionless pulley. Student, in this, if you look at the diagram, there is block A on which force P to cause the motion is applied down the plane. It is connected to a string which is taken around the frictionless pulley. Then it is connected to another block B, which is also resting on the same plane. How the motion will impend in this case? He say find the value P required to start the motion. So obviously block A will move down the plane. If A tends to go down, B will tend to go up. Here, students, there are two blocks are there. So we will be drawing two free body diagrams. Each free body diagram is without dimensions, will be example of concurrent force system. Total 4 unknowns can be determined from the 4 equilibrium condition. We always draw the free body diagram of the part on which there are less number of unknowns. Like in this case, we'll start with the free body diagram of block B, because it will have 2 unknowns. After that, we'll draw free body diagram block A, which will have initially 3 unknowns, but after you solve the FBD of block B, then we'll be left out with 2 unknowns. So we start with FBD of block P, understanding that impending motion of block will be up the P. Weight vertically down, 4 kg means 4 into 9.81, 39.24. Then plane is making 30 with horizontal, normal reaction will make 30 with vertical. So 39.24 cos 30, 39.24 sin 30. All right. Then impending motion is up the plane, friction is down. I've taken. Tension is always away from the body, so it is shown up the plane. Sigma Fy is equal to 0, N1 is equal to 39.24 cos 30. Sigma Fx is equal to 0, T is equal to 0.3 N1 plus 39.24 sin 30. Substitute the value of N1 out here, you get tension T. Now we come to FBD of block A. When we draw FBD of block A, weight vertical down, 8 into 9.81, 78.48. Plane is making 30 with horizontal, normal reaction make 30 with vertical. Weight is resolved, 78.48 cos 30, 78.48 sin. All right. Now, force P is applied down the plane. So I have shown it here like this. Tension T will be up the plane, away from the body. Right? Sigma Fy is equal to 0, N2 is equal to 78.48 cos 30. Sigma Fx is equal to 0 will be 78.48 sin 30 plus P. These are downward. Equal to T plus 0.3 N2. These are the upward forces. Substitute the value of N2 into it. Substitute the value of T into it. You get the value of P required to just start the motion of block A. So these are the two bodies connected by the string. String is taken around the frictionless pulley. So tension the string on the two sides will be equal. Whereas the blocks are resting on the rough surface. So there will be friction between the blocks and the plane. All right. We are, I'm reading question number 7. It's a dual problem. It's a dual problem. All right. Now read that. Two inclined planes, AC and BC, are inclined at 60 degree and 30 degree to the horizontal show at a 100 Newton block rest on the inclined plane BC. A rope is tied to a rope which passes over the smooth pulley at the ridge. The other end of the rope being connected to a block of W Newton resting on the plane AC. Determine the least and greatest value of W for which equilibrium is maintained. This problem has been taken from BJTI May 2017 examination. Looking at the diagram, let's come to the diagram part. If you look at the diagram on this side, see this is where a block of weight W connected to a string taken around frictionless pulley. It is connected to another block of weight 100. Block of weight weight of block 1 is not given. Weight of block 2 is given as 100 Newton. He is asking W be minimum and maximum for the equilibrium of the whole system. See, there are two cases that W will be maximum, greatest or largest possible when this block 1 will tend to go down and 2 will tend to go up. See, the wordings of the problem will decide direction of impending motion. I repeat once again, weight W will be maximum, largest, greatest possible only when block 1 goes down, tends to go down, and block 2 tends to go up. Whereas W will be minimum when block 1 tends to go up and block 2 tends to go down. So let's draw the free body diagram for the two cases. So first I'm taking W max. For W max, I have to start with free body diagram of block 2. Why? It will have two unknowns and FBD of the block 1 will have three unknowns initially. But one unknown is common. So that's why we should start from FBD of block 2 where we have only two unknowns. Now weight is vertically down 100 Newton. Plane is making 30 with horizontal. So normal reaction will make 30 with vertical. We resolve the weight 100 cos 30, 100 sin 30. Impending motion is up the plane. Friction will be down the plane 0.3 N1. Tension will be away from the body and it is up the plane. I write sigma Fy is equal to 0. N1 is 100 cos 30. Sigma Fx is equal to 0. T is equal to 0.3 N1 plus 100 sin 30. Substitute the value of N1, you get the value of T. Once the value of T is obtained from this free body diagram, now we can go to the other side. So we'll draw the free body diagram of weight W where this value of T can be substituted. Okay. Now we draw FBD of block 1. Now, when we draw FBD of block 1, weight W vertically down, plane is making 60 with horizontal, normal reaction makes 60 with vertical. So W cos and W sin. Impending motion is down the plane, friction is up the plane, tension is up. Now we write sigma Fy is equal to 0, N2 is W cos 30. Sigma Fx is equal to 0, T plus 0.22 N2 is equal to W sin 30. Substitute the value of N2, substitute the value of T, you will get the value of W. So this value of W will be maximum, largest, and greatest. We also understood that now second case will take W minimum. W will be minimum when block 1 tends to go up and block 2 tends to go down. So again, we start with free body diagram of block 2. Weight vertically down. Normal reaction make 30 with vertical. Weight is resolved 100 cos and 100 sin. Impending motion down. Friction is up. Tension is will be away from the body. Sigma Fy is equal to 0. N1 is 100 cos 30. Sigma Fx is equal to 0. T plus 0.3 N1 is 100 sin 30. Substitute the value of N1. You get T as 24.0. Then we draw FBD of block 1. When we draw FBD of block 1, weight W vertically down, plane is making 60 with horizontal, normal reaction makes 60 with vertical. All right, we resolve W, W cos, W sin. Impending motion is up the plane, friction will act down the plane. Friction will act down the plane. Tension T is away from the body. Sigma Fy is equal to 0 and N2 is W cos 60. Sigma Fx is equal to 0, T is equal to 0.2 N2 plus W sin 60. Substitute the value of N2 into it. Substitute the value of T, 24.02. Solve it, you get the value of W. That value of W is W minimum. W minimum or W smallest or W least. All right. Now we are ready to move to next problem, that is problem number 8. Two blocks A and B weighing 90 Newton and 60 Newton respectively placed on an inclined plane are connected by the string which is parallel to the plane as shown in the figure. Find the inclination, the minimum force P for the motion to impend in the direction of P. Take mu is equal to 0.2 for all surfaces of contact. Now, look at the diagram. He has applied force P at angle theta on 60 Newton force, which is resting on horizontal. He is asking the value of P required, minimum value P required for the impending motion to happen. So impending motion will definitely happen towards right. And if 60 Newton block tends to go towards right, 90 Newton block will tend to go up. All right. So let's draw the free body diagram of two blocks. Number of unknowns will be 2 on 90 Newton block. So we'll start first with 90 Newton block. Number of unknowns will be more on 60 Newton block. So we start with 90 Newton block, right? I called it as A. Weight vertically down 90 Newton. Plane is making 55 degrees horizontal, normal reaction 55 degrees vertical. So 90 cos 55, 90 sin 55. Impending motion up the plane, friction is down and tension T. Sigma Fy is equal to 0, N1 is 90 cos 55. Sigma Fx is equal to 0, T is equal to 0.2 N1 plus 90 sin 20, 55. So here N1 value substituted, you get the value of T as 84.0. As the two blocks are connected by this string, which is taken around the frictionless pulley, tension the string on the two sides will be equal. Now we draw FBD of block. Weight vertically down, normal reaction vertically up. Impending motion is towards right, so friction is towards left, 0.2 and 2. Tension is away from the body, that is to the left. P force applied at angle theta is resolved P cos theta, P sin theta. Right, sigma Fy is equal to 0, N2 up is equal to 60, N2 up plus P sin theta is equal to 60. Sigma Fx is equal to 0, P cos theta is equal to T plus 0.2 N2. All right. Now substitute the value of N2 into it. Substitute the value of N2. N2 comes out to be 60 minus P sin theta. You have substituted, you have simplified it. Then the value of P comes in this manner. P is equal to 96.05 upon 0.2 sin theta plus cos theta. He says that you have to find the value of P to be minimum. Minimum value of P is required. P is function of theta, right? P will be minimum when denominator is maximum. P will be minimum when denominator 0.2 sin theta plus cos theta should be maximum. That means first derivative of the denominator should be equal to 0. So 0.2 cos theta minus sin theta, we have differentiated this expression, 0.2 cos theta minus sin theta is equal. Then arrange the terms, sin theta upon cos theta is 0.2, that means tan theta is 0.2, theta is 11.3. Then substitute the value of theta in equation number 1, you get P, that is 94.185. So here there is little application of maximum minimum knowledge of your mathematics. All right, rest all was same as in other problems. All right. Question number 9. Find the weight WB so as to have its impending motion down the plane. Right, total take the weight of block is 2 kilonewton. The pin connected rod AB is initially in horizontal position. Now, if I look at this diagram, students, if you look at the diagram of this problem, you can see there is a block A of 2 kilonewton. There is a block B of weight WB, which is unknown. Coefficient of friction between the planes and the block is 0.2 on this side as well as on this side. This side inclination is 30 degrees, this side inclination is 45 degrees. What needs to be observed in this sum is that the rod connecting the two blocks is a two-force member. Rod connecting the two blocks is a two-force member, right? So that means it is subjected to axial force. As the rod is hinged at two ends without any loading in between, we assume that it is subjected to compressive force. Let F be the axial compressive force in the rod. We do not draw the free body diagram of the two-force member, as we do not draw the FBD of string, wire or cable. Now, for the given wordings of the problem, he is asking you to find out the value of W required for its motion to happen downward. So B will tend to go down, A will tend to go up. I'll start with free body diagram of block A because it will have initially two unknowns. Weight vertically down 2 kilonewton. Plane is making 30 degrees horizontal, reaction normal to it will make 30 with vertical, resolve 2 kilonewton. Along the plane, normal. Normal to the plane 2 cos 30. along the plane 2 sine 30. Impending motion up the plane, friction down the plane, point. This F is making 30 degree with the this force F is making 30 degree with the plane, as this 30 and this 30 will be alternate angle. F cos 30 will be component along the plane, F sin 30 will be normal. Let's write sigma Fy is equal to 0, up force is equal to down. N1 up is equal to F sin 30 plus 2 cos 30. Sigma Fx is equal to 0 will be F cos 30 is up the plane equal to 0.2 N1 plus 2 sin 30. So, substitute the value of N1 into it. You get the value of F is arrived at 1.758. So F is axial force. We assume to be in compression. It came out to be positive. That means our assumption has come out to be right. Now we draw FBD of block B. Now it will be workable because as the value F is known to you, so number of unknowns left out on FBD of block will be 2 only. Weight is vertically down WB. Plane is making 45 degree horizontal. Reaction normal to it will make 45 degree vertical. So WB cos and WB sin. Force F is going to make 45 degree with the plane. So F cos 45 and F sin 45. Impending motion is down the plane. Friction will be up the plane. यहाँ पे एक correction रह गया इसमें. Here FBD of this block B is down the plane. So ये जो friction है ना, this is up the plane. So there is a small correction in that. Although in the working I have taken it correctly. So I take sigma Fy is equal to 0, N2 is equal to F sin 45 plus WB cos 45. Okay? Sigma Fx is equal to 0. This now also in this now here in the free body diagram, sigma Fx is equal to 0. 0.2 N2 is down the plane. 0.2 is N2 is actually up the plane. What is mistake is that it is up the plane. So 0.2 N2 plus F cos 45 is equal to WB sin 45. So value of N2 will be substituted in this. F is already known to you. So you will get the value of WB max as 2.637 km. You get F as 2.637 km. So working, there is no correction in the working. Here in the free body diagram, there is one correction that as the impending motion is down the plane, friction will act up the plane. So in the working, it has been considered up the plane. Also, ये जो एक arrow है ना, ये थोड़ा extra आ गया. This is a printing error. On FBD of block B, there is no force this one. So this is actually, it's not to be considered. All right. So I think you understood that correction in the diagram. This friction will be up the plane and this arrow is extra. It has come by this is a printing error. All right. Now here I have written a note. What note I have written? See, as we are already understood in the previous sum, in this case, W will be maximum when B tends to go down, A tends to go. W will be minimum when A tends to go down and B tends to go up. This is what I have. So it is, you have solved the problem for one case, that is WB max. But if it is to be solved for W minimum, then direction of impending motion will be what? A will tend to go down. All right. And B will tend to go up. Okay. So let's come to question number 10. The following figure shows a block A held in equilibrium on an inclined plane by moment M applied to the link BC. Link AB and link BC are hinged at B. The weight of block is 10 kilonewton. The rod BC is 2 meters long. Assume the links to be weightless and hinges to be ideally smooth. Calculate M to just start the motion of the block upwards. Take coefficient of friction between the block and plane to be find. Students, in this case, there are in this system, there are three components are involved. What are the three components involved in the block? One is block 10 kilonewton, which is without dimensions, so will be example of concurrent forces. You have a link AB, which is hinged at both ends without any loading in between, so it will be example of two force member. Then you have a link BC, which is horizontal. It is subjected to the movement at C, so it will not be two force member. So first we realize that link AB is example of two force member. But we realize that link AB is two force member since it is hinged at both ends without any loading in between. So let us assume that F is the axial tensile force in link A. Then we first draw free body diagram of block A. When I draw FBD of block A, its weight will act vertically down 10. Plane is making angle theta with horizontal, which we have defined it at 3, 4. So tan theta is 3 by 4. Cos theta is 4 by 5, 3, 4, 5 right angle triangle, 0.8. Sin theta is 3 by 5, that is 0.6. Tan theta is 3 by 4, that gets in the value theta is 36.8, which will need it, that's why we have found it. Then plane is making 30 degree with, plane is making theta with horizontal, reaction normal to it will make theta with vertical. So tan cos theta, tan sin theta. F is making 30 degree with the plane, so F cos and F sin. Impending motion is up the plane, friction is down the plane. So let's write sigma Fy is equal to sigma Fy is what? N1 plus F sin 30 is tan cos theta. Sigma Fy is equal to 0 we got it. Then sigma Fx is equal to 0 will be F cos 30 is up the plane equal to 0.2 N1 plus tan sin theta. We simplified it and it came F cos 30 0.2 N1 plus 6. Solving equation number 1 and 2. You have two unknowns, that is N1 and F. Solving them, you get N1 and F. The value of F came out to be positive. That means assume direction of axial force, or we assume the axial force to be tensile. It has come out to be right. Now, we do not draw FBD of link AB as it is a two-force member. Now, since he is asking you to find the value M required for impending motion of block A up the plane, so obviously that's why we assume the axial force in the link AB is to be tensile, because if it is tensile, then only block will be pulled up the plane. Now we draw FBD of link BC. At C there is a hinge, so two reactions HC and BC. M is external moment applied, which is to be formed. At B there is axial force in link AB, which is tensile. I have written F. But this time link BC is drawn horizontal, so I need its inclination with the horizontal. So link axial force in link AB is making angle theta plus 30. Can you see that? It was making 30 degree with the plane, as you can see over here also. This link AB is making 30 degree with the plane, all right, and plane is making angle theta with the horizontal. So total angle what force is making, F is making with the horizontal is 30 plus theta. What is making 30 plus theta? All right. So this comes out to be 66.87. So we resolve the force F cos 66.87, F sin 66.87. So we write sigma MC is equal to 0. M is clockwise. HCVC will go off. F cos will also go off. F sin 66.87 into 2. F 66.87 into 2. You take sigma MC is equal to. This is example of general force system. This is example of general force system. And right, three unknowns are there, HCVC and M. But I do not want HCVC. So we took moment equilibrium condition about it. Sigma MC is equal to 0. M is clockwise. Right, HCVC will give 0 moment, F cos will also give 0 moment, F sin 66.87 into 2. That gets you 14.47. Now, another type of the problem we are starting where one block is resting over the other. So far, what you saw that initially we took 3-4 problems where there was single block involved in the problem. After that, we took the problems of the two blocks connected by the string, and then we took few problems where the two blocks were connected by the rod also. Now we are coming across another problem where there are two blocks and one block is resting over the other. One block is resting over the other. So I'm reading question number 11. Two blocks A 100 Newton and B 150 Newton and resting on the ground as shown in the figure. Coefficient of friction between the ground and the block B is 0.1 and that between block B and A is 0.3. Find the minimum value of weight P in the pen so that motion starts. Well, students, you see that in this case, there are two blocks. One is resting over the other. One is resting over the other. You have 100 Newton block A, which is resting over 150 Newton block B. 100 Newton block A is connected to a string, which is taken around the frictionless pulley, and then there is a pen in which force P is applied. as he's asking you to find the value P required to just start the motion. So that means first you should understand that tension in the string connecting the 100 Newton block is P only. So it is as good as force P is applied on block A at 30-degree angle so as to start the motion. All right. So tension in the string connecting the block A is P, which is applied at 30-degree. So you have to find the minimum value P required to start the motion. So student, there are two possibilities of impending motion here. One is that only block A starts moving, and another is that block A and B start moving together as one unit. Now we come to here. First case we are taking impending motion of block A. When we take impending motion of block A, weight will be vertically down 100 Newton, normal reaction N1. Impending motion to the right, friction is to the left. Friction between A and B is 0.3, so 0.3. Force P is applied at 30 degrees horizontal, P cos and P sin. If you write sigma Fy is equal to 0, N1 plus P sin 30 is 100. Sigma Fx is equal to 0, P cos 30 is 0.3. Solving 1 and 2, you get N1. So in the first case, you get the minimum value P required to start the motion is 29.5. The value P required to start the motion is 29.53 when only block A just starts. Now, impending motion of block A and B as 1 unit. If you consider FBD of the two blocks as 1 unit, total weight of the system is 250 Newton. No normal reaction, no friction force between the two will come into consideration because the two are acting as one. So weight is vertically down 250, normal reaction N2 upward, impending motion to the right, friction is to the left, friction between the block B and the plane is 0.1. Force P applied at 30 degree, right? P cos and P sin. Identically, we apply same two equilibrium conditions. Sigma Fy is equal to 0 gives you N2 plus P sin 30 is 250. Sigma Fx is equal to 0, P cos 30 is 0.1. And solving the two equations, you get N2 is 236.53 and value of P as 27.2. Well, students, in the first case, when we consider the impending motion of block A, then we found value P required is 29.5. In the second case, when both the blocks start moving together as a one unit, value of P is 27.29. So hence, the minimum value of P required to start the motion is 27.29. And how it will happen? When the two blocks are moving together as one. Now, we come to next problem, that is problem number 12. Find force required to pull block B as shown. Coefficient of friction between A and B is 0.3 and between B and floor is 0.25. Mass of A is 40 kg and B is 60 kg. If you look at the diagram, students, you have one block resting over the other. Force causing motion is being applied on the lower block. Motion of upper block is restricted by connecting it to a string. So there will be only one possibility of impending motion. Here, the lower block will, as the force causing motion is applied on the lower block, it tends to go towards right. Whereas the motion of the upper block will not be happen. It is under restricted motion because motion is restricted by string. So in such problems, we draw the free body diagram of the block first, which goes into impending motion first. So we will draw FBD of block B first. Now, FBD of block B. Force P applied to the right, impending motion to the right. Weight vertically down 16 to 9.81. Normal reaction N1 and N. Impending motion is to the right, friction will be towards, all right, 0.3 N1 and 0.3 N. Whereas friction between the block B and plane is 0.25 and friction between the block B and A is 0.3, right? But we don't solve this first. Don't solve this first. After that, we'll draw FBD of block A. For FBD of block A, weight vertically down 14 to 9.81. Normal reaction N1, tension T at 30 degree, T cos and T sin. Here at now in this type of the problems, this friction is shown from here equal and opposite. Here the friction is from this side is 0.3 N1, which we understood it from this direction impending motion. So here 0.3 N1 is to the left. So here it will be 0.3 N1. Here it is to the left. So here it will be to the right. So friction between the two blocks will be equal and opposite. So here friction is to the left, here friction will be to the right. So we first solve block A, FBD. So FBD of block A, sigma Fy is equal to 0 is N1 plus T sin 30 is 392.4. Sigma Fx is equal to 0, T cos 30 is 0.3 N. Solving the two equations, you get N1 and N. Now we draw FBD of block B. Sigma Fy is equal to 0 gives you N2 is equal to N1 plus 588.6. Sigma Fx is equal to 0, P is equal to 0.3 N1 plus 0.25 N2. Substitute the value of N1 and N2, you get the value of P. So here there is only one possibility of impending motion, and that's what is the block B. As force causing motion is applied on block B, it will tend to move towards right. So first we draw FBD of block B, and then we draw FBD of block A. Friction force between block A and B is shown equal and opposite. So FBD of block B is drawn first, then we come to FBD of block A, and then we complete the free body diagram. Although when we start applying equilibrium condition, we'll start applying from block A because number of unknown is 2 over here. And then we go to the FBD of block. Well, students, now I'm coming to the last problem of this lecture. We'll cover some more problems of this type of block friction even in the second lecture also. And they will be covering the problems of type 2, that is wedge friction, and type 3, that is ladder friction. So 2 more types are remaining, which will be covered in the next lecture. In the next lecture also, I'll be taking 4 or 5 problems from the block friction, 5 or 6 problems from the wedge friction, and 4 problems from the ladder friction. So that will be the concluding lecture on friction. So for this lecture, this is our last problem, as 13 problems are taken on the block friction. This is my 13th problem. Now I'm reading it. What should be the value of theta so that motion of block A imprints down the plane? Coefficient of friction mu for all surfaces 1 by 3. Mass of block A is 40 kg and mass of block B is 13.5 kg. Problem has been asked in Mumbai University examination twice in 2011 as well as in 2000. Now, if you look at the diagram, what we find that here there is a you have the inclined plane with inclination theta. There is a block A is resting on it. Above that is block B. Motion of block B is restricted as it is connected to the string and which is connected to the another vertical plane. Now, here impending motion of block A will be there. See, motion of block B will not happen. It is under as it is connected to the string, so its motion will not happen. But we will be applying equilibrium condition on block B2. First, we draw FBD of block A as it goes into impending motion down the plane. Weight is vertically down of the block A, that is 40 into 9.81, 92.4. Normal reaction N1 and N2. Normal reactions are always towards the body. Impending motion block A is down the plane, so friction will be upward. On this surface 1 by 3 N2, here 1 by 3 N1. All right. But if you look at it, there will be 3 unknowns. What are the 3 unknowns? N1, N2, and theta. So then we draw free body diagram of block. From block B, it does not go into motion. Its weight is vertically down, 13.5 into 9.81, 132.435. Right? Here friction is up the plane, so here friction will be down. Equal and opposite. Normal reaction N2. As the plane is making same theta with horizontal, normal reaction will make theta with vertical. So 132.435 cos and sin. Start solving it from here. Sigma Fy is equal to 0 is N2 is equal to 132.435 cos theta. Sigma Fx is equal to 0 is T is equal to 1 by 3 N2 plus 132.435 sin. All right. T is not asked, so we have not done further simplification. We apply sigma Fy is equal to 0 on block A. N2 is equal to N1 is equal to N2 plus 392.48 cos theta. We get the value of N1. Then sigma Fx is equal to 0, 392.48 sin theta is equal to 1 by 3 N2 plus 1 by 3. N1, N2 values can be substituted. N2 is 132.435 cos theta. N1 is from here 524.835 cos theta. Add them up, you get 657.27 cos theta. On the left hand side on simplification, 1177.2 sin theta. Sin theta upon cos theta gives you 657.27 upon 1177.2. So tan theta is 0.558 or theta is 29. So at this value of theta, that is 29.18 degree, the block A will be on the verge of going. So well students, with this I conclude this lecture. Now there will be one more lecture of friction, that will be second part of the friction chapter, where we will complete the chapter. I'll take up maybe 10-15 more problems will be taken in the next lecture. Okay, thank you very much.